I think we're live. Let me just check YouTube.
Not yet.
Yeah, not yet on YouTube.
Yeah, we're live.
Live, guys, can you hear us?
Yes. Yeah, I think we're live now. Yes. Cool.
So, hi everyone, and welcome to the first episode. Welcome to the first episode of JavaScript. Today on the show, we are joined by the awesome Minko Gechev. Hi, Minko. How are you doing?
Hello, I'm good. Thank you. How are you?
Thank you for joining us. Glad to have you today, and welcome to the Moroccan Angular developer community.
Thank you for having me. I'm really excited about being with you today.
Minko is an engineer in the Angular team at Google, based in San Francisco. He has been working on a lot of open source projects like Guess.js, Codelizer.com, Revive.run, and community-driven Angular style guide. Today we're gonna talk about the state of Angular. I guess you have some new cool stuff to share with us, all right?
Yeah, I have some updates around Angular version 9 mostly.
Great.
Cool.
On the panel, we have Gechev and Elias. Thank you guys for helping on that.
Hello.
Hello.
We gonna keep question for the end of the talk. So if you have any question, feel free to post them as comments on YouTube or Facebook in Arabic, French, or English. We will then show them and translate them if needed. Last but not least, we will play together a quiz game, so remain attentive to what they will be announced. Minko, the stage is yours if you are ready.
Yeah, let me share my screen.
Yeah.
Here we go. Okay, do you see my screen now?
Yeah.
All right, perfect. So my name is Minko Gechev. I'm working at the Angular team at Google, where we're building the Angular framework and like all the surrounding packages that are contributing to like providing you a tools for developing user applications with the framework. Today in this presentation, I would want to share what is the current state of Angular. And I would want to put it into the context of like pretty much how we came here. We're going to look at things from slightly more theoretical perspective. We're going to discuss dynamic versus static systems and how we are trying to find the balance between these two for Angular. In general, the biggest news is that Angular version 9.1 is out. It has been out for a while now. In fact, we published about 7 patch versions in the meantime. But version 9 itself, it brought the biggest improvement that we have been working on for about 2 years now, which is Ivy. So in order to take advantage of version 9 and all the improvements that come with it, all you need to do is just run ng update at angular/CLI at angular/core, and we're going to automatically migrate your application to the latest version of Angular. We're going to update your dependencies, project structure, as well as your source code, if there are any code transformations that are necessary for your application. So the biggest improvements that we brought with version 9 are smaller bundles, faster builds. The framework became a little bit simpler. We were able to remove one of the properties, for example, of ng module. We improved internationalization where we introduced some runtime elements. There are improvements in Universal. We're going to discuss them in details, better build errors, better debugging, and of course, type checking. So in this talk, particularly today, we're going to focus on the first 5. We're going to see why your bundles are getting smaller, and we're going to go all the way to Angular Universal and what you can expect from it. Before that, let's start with the more theoretical overview. Usually, I like to talk about predictable versus flexible systems. And these concepts are often like quite the opposite. So if you make one system more predictable, it usually gets less flexible. Because, well, if it is predictable and you're aware of everything that's going to happen at build time, then at runtime you have less flexibility in order to introduce dynamic behavior. In the context of programming languages and frameworks, we often refer to these predictable and flexible systems as static versus dynamic. To put more like context onto this picture here, if you look at programming languages, for instance, Haskell. Haskell is a very static programming language, which is going to be on the left side of the axis. It is very predictable. It has very strict type system, and it checks for errors, but at the same time, it puts some brakes on us when we want to do very dynamic things at runtime. On the other side of the spectrum, we have JavaScript and Ruby. They are super flexible languages, very dynamic, and we have fewer compile time guarantees with them. TypeScript is going to be somewhere in the middle. We have very dynamic behavior since, well, it is based on JavaScript, but at the same time, we have a type system. And this type system, it helps us to put some boundaries and perform some better compile time checks. One interesting property of this picture is that if we start with a system and we make it very static initially, such as Haskell, it is very restrictive. It is easier to make it more dynamic because we should just make it a little bit more permissive, right? We should just allow folks to do more things with it at runtime. So this transition is simple. We can make a system static, and from there on, we can transition it to a more dynamic one. However, if we start with a very dynamic system, with something like Ruby or JavaScript, it is very hard for us to make it super static and get some guarantees, get very strict guarantees at compile time. Here are even more like practical concepts that are going to put this into an even more specific context. If we have a static system, we have great compile time optimizations because the compiler is able to read our source code and analyze it much simpler. There are fewer runtime dependencies. We have excellent ID and text editor support thanks to the same reasons. We can just look at the source code, and from there, we can extract all the different auto-completion suggestions, let's say. Stricter type checking is another property of static systems, and we can even visualize the source code. We can just look at the source code and statically, without running the application, figure out what are the individual components of this code base and visualize them with their relations across each other. When we're talking about dynamic systems, though, we have much easier lazy loading, because this is something that can happen at runtime. Depending on a runtime information that we have from our application, we can directly load a module from somewhere in the network. We can dynamically assemble the user interface even and have faster builds, because we need to do fewer things at build time. With dynamic system, we may even not have runtime, build time at all, because we may not have any type system, or we may not need any transformation of the source code. We can just directly interpret it. AngularJS, for example, is on this right side of the spectrum. It is a very dynamic framework, and it doesn't provide some of the guarantees that we would want a framework to provide, such as Angular, right? That's why with Angular, we started by making it really static. We wanted to provide great compile time optimizations, excellent text editor support, strict type checking, and even allow you to visualize the source code. There are different third-party tools which allow you to do that. On the other side, we decided that it is very static and provides great guarantees, but we may want to enable some runtime behavior as well. That is why in version 4.0, to make the bundle smaller and to make the framework slightly more static, slightly more dynamic, we worked on a runtime, on a very thin runtime. In version 9 now, we went even closer to the dynamic part of the spectrum. Now notice that here I have placed Angular version 9 in the middle. So according to this diagram, it takes pretty much the best from both worlds. Whether this is the case I cannot promise, but so far we think that we are taking the best from both worlds. At the same time, this is not a consistent situation that we're in. At certain point, different requirements from both users and the web platform are going to change, and this ideal center is going to be somewhere else. So we'll have to reflect and react accordingly. Now, Angular is now more dynamic for sure, but at the same time, it is not too dynamic. We still can perform really great compile time type checking, and we have even better compile time optimizations that we're doing right now with Ivy. But you can see that how we went from the originally with AngularJS from the very right of this diagram to the left with Angular 2, and after that with Angular version 4, we went a little bit more on the right, and now we're somewhere in the middle. This approach really reminds me of a machine learning algorithm called the gradient descent optimization algorithm. There, we're pretty much trying to model, trying to make predictions for the environment, and we're building this model which has an error function. So with the gradient descent, we're just trying to minimize the error. We're trying to be as optimal as possible. Just like with Angular, we're trying to serve developers as best, like as better as possible. Like we want to provide the best guarantees when building applications, as well as we want to allow you some flexibility at runtime. So with the gradient descent, you first do something. You build your model, and right after that, you collect feedback from the environment, and in the end, you adjust your direction when you receive this feedback. In our case, though, collecting feedback from the environment is a really pleasant process. It is something that I really enjoy doing. It is connected to collaborating with all these fantastic smart developers worldwide, like talking to people just like today on meetups and seeing your pains and seeing how we can do better. At the same time, we also have one large organization that we're working with. This is Google. So with Google, we're able to collaborate really closely as well. And originally, before I joined the Angular team, I thought that Google is the special case where it pretty much dictates the direction of Angular. Later on, now working at Google for about 2 years now, I realized that things are slightly different. In fact, the requirements that Google has and the requirements that we're getting from community are pretty much the same. We have many diverse applications, both externally, outside of Google, and internally. And at the same time, the differences between how people are building web apps are very small. They're mostly inside of the build system. So that is how we're able to bring Angular to everyone and move it forward by working together with both external open source developers, consultancy companies, enterprises, and different teams at Google as well. Now let's talk about how we made the framework faster, how we made the builds faster in Angular version 9. One of the main things that we did is just to do fewer things. So that was our solution. Instead of doing a lot of redundant steps, the steps that we did in version 8 and before, now we're doing fewer of them. If you look at our previous version of the Angular compiler, the so-called view engine, it is going to output 5 different files from your component files. So if you have your app component here, with the previous version of the compiler, we'll generate the ng factory file for your component that is responsible for instantiating it and for rendering the ng summary, metadata, component.js, and component.dts. And from these files, we are encoding different kind of metadata in different places. We're just adding rendering instructions, instantiation logic, and so on and so forth. With Ivy, though, we found a way to do that much more efficiently with only 2 files. So now we're generating just the app.component.js file, which contains all the instantiation logic and rendering instructions, and the app.component.dts file, which contains not only TypeScript type definitions, but also different metadata properties. So the faster builds are primarily caused by the fact that we're no longer generating factories. We're no longer generating metadata.json files. And at the same time, we enabled ahead of time compilation by default in development mode. So this is thanks to the incremental AOT builds that the Angular compiler performs right now. Another improvement is in the bundle size. So the total bundle size with Ivy applications dropped. For some applications, it dropped more compared to others. But in general, for small applications, we're observing about 30% bundle size improvement. For medium applications, either 2% or no improvement. It depends on the type of your application. I'm going to tell exactly why is this the case in a second. And for large applications, we're observing the largest amount of improvement. So small applications, now they can have smaller bundles because of the tree shakeability that we introduced in Ivy. Now you're able to use only the pieces of the framework that you actually, you're able to take only the piece of the framework that you actually use in your application. And small applications, they don't usually use many parts of the framework. So that's why we observe about 30% improvement. Large applications are gaining from the fact that our instruction format right now is much more compact. We don't generate too much source code from your templates. And usually this has significant impact on your apps. Medium applications, however, they use most of the framework and they don't have that many templates to gain benefits from the more compact instruction set that we generate. So that's why we're not observing that significant improvements there. However, some folks from community reported that they observed some significant bundle size improvements. For example, here you can see that the biggest lazy loaded module of this application dropped from 900 kilobytes to 500. On Hacker News, some folks reported that their bundle size improved with over 31% right after they run ng update. So that is a pretty significant improvement for pretty low effort. And again, we're just making the framework smaller by allowing you to tree shake to get rid of the pieces of the framework that you're not using in your applications. And also, we're generating less code. On top of that, since we changed the way that we're rendering your applications, we were able to get rid of some pieces of the framework which were related to the management of the ng factories that we used to generate. So this is some kind of an internal thing that you shouldn't worry about. This is just an extra information for the folks who are interested. Now, let me talk a little bit about internationalization before going to the final part of the presentation, server-side rendering. The internationalization in version 2 to version 8 worked the following way. So you can have different localizations in your application. For each one of your localizations, we're going to pass them to the compiler, and we're going to generate n different versions of your application. So if you have n different languages, let's say 5 different languages, we're going to run the Angular compiler 5 different times and generate 5 different versions of your application. So this may sound a little bit like an overhead, and it is. But the fact that we generate different versions of your application for different localizations is quite intentional. This is caused by the fact that we want to focus on static optimizations. We have the assumption here that most of the users in your application, they are not going to constantly change from one language to another. That is why a reload of the page, when they change from one language to another, is pretty much natural. It's something that is not going to happen too often, so this overhead is worth it. At the same time, when we embed the individual strings from the specific language as part of your application bundles and templates, we're performing significant optimizations. We're taking only the pieces of the language files that you're actually using, so we have this kind of like tree shakeability, let's say, for localizations. And at the same time, we don't have to generate any extra content, any extra instructions for different bindings for variables that are bound to specific localizations. So this way we can make your application smaller and faster at runtime. But at the same time, we still need to compile your application multiple times. And this is really far from ideal. That is why in version 9 with Ivy, we changed the way that we're performing this entire compilation pipeline. Now what we do is first take your source code and compile it with ngC and add some initialization markers. Right after that, we have this link and optimization phase. And finally, we're replacing all these initialization markers with individual strings associated with the particular language that you want to build your application for. We still produce different versions of your application for the individual localizations, but this time we're performing compilation only a single time, which is going to make your builds much faster. And finally, before going to the Q&A session, I would want to talk a little bit about the Angular universal improvements that we did as part of Angular version 9. So when traveling for events, talking to most external developers, some of the challenges that people are facing with Universal, our server-side rendering approach, is change refresh time and deployment. For change refresh time, people are usually complaining that when they have to make a change in their application, what is expected from them after that to do is to compile both the client and the server, and right after that run their development server for Angular Universal. And this takes a lot of time. It also has some mental overhead, like mental context switching. Usually building your client, this takes a couple of seconds or sometimes even minutes. Imagine you make a small change. You would have to start the compilation process. It's going to take several minutes while you're going to open social media and lose some time there. Or, I don't like, you're going to get a delivery and you're going to lose another 30 minutes there. And this mental context switching is pretty tough and time consuming. So what we did is to introduce an Angular SSR serve builder. Now, when you add ng Universal Express Engine to your application, and when you run ng-run, the name of your project colon ng serve SSR, we're going to run a similar builder to ng-serve. So this is going to be ng-serve-like behavior, but this time it is going to work for applications with enabled server-side rendering. We're going to start watching the files of both your client and your server, and when we detect that any of them has changed, we're going to reboot both your client and server, and right after that, refresh your browser. This is not a replacement of ng-serve though. Since we're performing more work, I wouldn't recommend you to just use serve SSR instead of ng-serve, but it is pretty convenient when you're making changes that are impacting both your client and your server, or primarily your server, and you would want to have better round-trip time. To take advantage of this feature, you just run ng update, ng universal / express engine, and that's all. This feature was developed in collaboration between Alan from the Angular CLI team and Manfred, who is one of our very committed collaborators. It's a huge pleasure working with both of them. Now, deployment. So deployment of Angular Universal applications is usually not dramatically hard, but still it involves some boilerplate, and often you'd have to fine-tune different configuration parameters. And this is, again, an overhead that it shouldn't be necessary. Like, we can automate the process much further. That is why we paired forces together with the Firebase team, and we worked on the ng-deploy builder for Angular Universal applications. You need to add Angular Fire to your project with ng-add. This is going to install some dependencies, and right after that, it is going to look at your project and detect whether it is an Angular Universal one or not. If it is an Angular Universal project, it is going to ask you to deploy it as a Firebase function. Here we can agree, and when you agree, it is going to continue with the installation of dependencies. Right after that, it is going to fetch the list of projects that you have from Firebase, and finally you can just run ng-deploy once you select a project. Once you run this command, we're going to perform the most optimal build possible that we're capable of performing at a certain point, and we're going to deploy all your static assets to a CDN. Right after that, we're going to deploy your server as a Firebase function and output an URL in the console. When you click on this URL, you're going to see your application, which is now server-side rendered. So this is how with 2 commands, you can go from Angular Universal Application in development to Angular Universal Application running on Firebase functions and hosting. So frequent problem, or kind of potential optimization that we can do, at least with server-side rendering, is something that we observe when multiple people are opening the same page all over again. Now imagine we have user A, and they open certain page. We send a request to the server, we render this page, and we return it to user A. Right after that, user B can open the exact same page. So we need to render the exact same content. That's fine, but what if we have 100,000 or like 1 million users opening the same page, generating the same content? This is kind of redundant work. We need to pay for the server for doing this work if you're using a cloud engine, or otherwise we'd have to pay for like electricity, or we'll have to pay for expanding our on-prem solution. So in all cases, this is expensive, and many people are solving this problem by introducing caching. When the user sends a request to the server, this request first goes to a caching layer. From this caching layer, we're checking whether there is an associated response with the request. And if there is one, we're directly reading it from there and returning it to the client. Alternatively, we're going to the server, rendering the page, and putting it into the caching layer. And that's it. Although this is a solution to a certain extent, it introduces different complexities. For example, we need to think about caching validation. We need to think about what exactly key we should use for this request that we're sending to the server. Like what key from the request we should get in order to associate it with the response that we got from the server-side rendering logic. That is why I often recommend to folks who have mostly static sites to use pre-rendering. Pre-rendering is something similar to server-side rendering, but with the difference where you're running the server-side rendering logic. So you can run Universal on the client, you can run Universal on the server for sure. This is server-side rendering. But you can also use Universal as part of your build process. And this is the so-called pre-rendering. Here is an example. In order to run pre-rendering for your application with Angular version 9, all you need to do is just run ng-add ng-universal express engine, and right after that run ng-run the name of your project pre-render. Here we're going to pretty much look at all your routes in your application. We're going to figure out which are the routes which don't have any routing parameters. And from there, we're going to run Angular Universal as part of your build process against each of these routes. And we're going to just generate a bunch of static HTML files. When you run ng-run, the name of your application pre-render, we're first going to build your application though, and this build process takes some time. The pre-rendering phase is pretty optimized, so for 800 pages, it is going to take less than 2 seconds. It still depends on your pages, but we optimize it so we are running the individual pre-rendering logic in separate processes. Some folks from community, for example, Steve here, he noticed that he rendered 10,000 pages for about 75 seconds. And I'm sure that about maybe 16 or 50, maybe 60 or 50 of these seconds were actually spent in building the application. So the actual pre-rendering, in my opinion, happened for about like 25 or 15 seconds because of the optimization. So 10,000 pages for 15 seconds is pretty decent. Now, with having such better pre-rendering logic in Universal, which is now a first-class citizen in the Angular Universal package, we have much better support for the Jamstack. The Jamstack is a way for building applications just by using JavaScript, APIs, and markup, without thinking about any server logic. There is also a community project called Scully. We're collaborating with them closer so that they can bring a full-fledged static site generator for Angular. It is a complementary project to Universal. Universal provides only pre-rendering in a specific way by using Universal, our server-side rendering logic. Scully, on the other side, it does pre-rendering, this time by using a headless browser, which has its trade-offs. On top of that, Scully also has a plugin ecosystem which allows you to fetch data from wherever you want. So it is a pretty powerful solution that I would recommend you to look at. Notice how most of these things we developed with collaboration, either by collecting feedback from folks or just by working together with different teams or with different individuals from community or from companies. That's a really powerful thing in open source, and I'm really happy to be able to be working on open source projects with everyone. Yeah, that was pretty much everything. Thank you very much for your attention. I would love to get your questions. If you have feedback for a talk, please leave it at mgv.io/talk.
Yeah, thank you, Minko.
Thank you very much.
That's pretty good. Yeah, we have the first question is from Yassine Sabri. Did you read the question, Minko?
Yeah, the question is for Ivy in version 9, everything is done under the hood. Is there any plans to add some Ivy interactions and coding logic to reduce more the bundle size in production? Yeah, so exactly that was our point, to change everything under the hood so that and not break anyone. If you think about Ivy, it is in fact an entire rewrite of Angular. And because we have a lot of APIs, that was really hard thing to make it backwards compatible. So we want to keep this under the hood. If we can reduce your bundles automatically without asking you to do anything, that's what we would prefer to do. Because taking care of performance optimizations is something that you can definitely do, but at the same time, it's better if you get it for free. Some things which we can improve further in order to make to allow you to shrink your bundle sizes is to make more robust solution for component level code splitting. There you will be able to load individual components much simpler by one by another, but for this we would have to also think about optional engine modules in Angular and a few other things. So this is something that is probably coming sometime in the future. We're not sure when exactly.
Yeah. Have a second one.
How would the cache work with the CDN? Yeah, that's for server-side rendering, I guess. Yeah, with the CDN, there are different browser caches, but in general, the CDN is something which has like zero logic. It is not supposed to. You're not supposed to run any computational, any heavy computation on the CDN. There is some work in this direction by Cloudflare who allow you to run CDN workers, but they are mostly for different purposes. When you're using Universal, though, in order to have caching, I wouldn't think about CDN at all. You can have in-memory cache with something like Redis, let's say, or some other solution. And the caching is not related to CDN in this particular case. It is mostly related to your own compute engine, on-demand compute engine, like Firebase functions or Cloud Run or Cloud Functions or something around these lines. And the caching layer is going to be somewhere around this logic. So it is going to be aware of your Firebase function. It is going to take the response from the Firebase function and put it somewhere else. So the caching logic is not related to a CDN.
Yeah, thank you. There is a little question by Ilyas about Bezier. I think he's a little bit confused.
Yeah, the Bezo is it mostly aims to speed up the builds. It is not going to make the bundle smaller. Bezo is the build system. Yeah, so notice when I mentioned that there is a slight difference between the external world, and Google. The only difference, in fact, is in the build system. Internally, we're using Bezo, and externally, most folks are using Webpack. So that's the difference. And So for most cases, for most folks, probably Webpack makes more sense compared to Bazel, especially if you don't have an enormous repository. Bazel is aiming to improve the build time of your application, not particularly the bundle size. You can use Bazel today if you want to. There are rules, Node.js, I believe that's how they're called. They're under the Bazel organization. On the Angular team, we're not focused on providing support for Bazel at this point. We did an experiment with Angular Bazel and integration with the Angular CLI, but we realized that this way we were hiding some of the benefits that you're getting from incremental builds. So I would recommend you to, if you use Bazel, to maintain build files yourself.
Yeah, gotcha.
Yeah, this is my question. So, is the localization now supported in TypeScript code? So today we only have this in template code. Do we have this?
Yeah.
In TypeScript? Yeah.
We didn't change anything around the. Yeah, it is still in templates.
Okay.
Yes, another one from Abdelghani.
Yeah, what is the?
It's a big
What
one.
is the? What is the? I guess the implication of processing Angular component into a DTS file after IV compilation? Is there another step that will transform the generated DTS to JS code before delivery to the browser? Yeah, so we generate both DTS and JS files. In the DTS files, we are only using them for type checking. And if you're building a library, we're going to use the DTS files also for just figuring out what ng modules and what component metadata, like what component selectors and what component like view encapsulation and so on and so forth you have in this library. So we're generating both of them. And to the browser, we're only delivering JavaScript. This is only part of the build step, the DTS files.
Yep, catch up. We'll take just the latest one from Elias.
Yeah. This is my question. Yeah. So this question, I think this feature is the most requested from the community, is to bootstrap a component. What can you say about that? Can we bootstrap a component without a module? And does it will change the behavior of our ng modules?
Yeah, that's a great question. It is one of the most requested features. Maybe reactive forms having better typings. This is the most requested from our observations. This is something that we're looking at as well. So currently you can render individual components without having ng modules by using private APIs. Ultimately, we would want to make these APIs public, and we would want to have a better way to declare exactly the components, the pipes, and the directives that you're using in a particular component without having ng module at all. This is something that we're looking at. We have different proposed solutions, but we don't have timeline for when we will be able to deliver it. I believe that we will deliver it at certain points. We just want to make sure that we are considering all the different risks. As you mentioned, this may change the structure of an Angular application. And one of our main goals is to keep the Angular application structure consistent. So this is something that we should figure out how this is going to impact projects and how we should implement it so that the impact is as small as possible. But definitely something that we are looking at.
Yeah, thank you.
So we will no longer have ng modules in the future?
They're not going away for sure, because there are a lot of Angular applications that are using ng modules, but we can make them optional. So if you want to build applications without ng modules, you have the option.
So we will have different structure of Angular apps, because the benefits of Angular is having this common structure between all Angular apps. If we are going to lose the ng modules, we are going to lose this structure, this common structure between the Angular apps. Yeah.
So another alternative is to keep the current structure. You can just remove your ng module, and instead of having the imports in an ng module, we can place them in kind of the root components in this part of your application. So we're going to preserve the component structure. We don't want to have many different ways of building applications. That's why we are cautious on introducing this feature. We just don't want to break things.
Yeah.
Yeah, great. Thank you.
Okay.
Yeah, sure.
Yeah, I think we are done. We just start a little quiz game. So guys, please connect you on kahoot.at using the code shown on the screen. We have Choki and Abdel. Are waiting for you guys.
Share the link.
I share it on comment. People thanking you on comment, Minko. Yeah, I think we can go on. Yes.
Okay, I'm not going to answer here.
Yeah, first one.
Oh, that's really cool. Really cool initiative with the quiz.
Okay. Let's move on to the second one. Ilfo, congratulations. You are on the top of the list.
Yeah, it's me. That's a tricky one.
Aha. Minko, any comment on this one?
Yeah, Angular's Ivy became a little bit more dynamic. Yeah, that's
correct.
That's actually great. It also tests whether I presented my content well. If most of the answers are accurate, then I did fine.
Yeah.
Yeah.
I'm going to be sending hints in the chat so that people can have good performance. Oh, that's a good question. I don't know either. Oh, okay. I know.
If you don't know, we definitely don't know.
There is one answer testing tool. Can you tell us, Minko, what AV means quickly?
Well, there are different interpretations, but so Ivy in general, because it is the fourth version of the Angular render, it starts with like 4 in Latin is
Ivy.
starting characters is I and V, right? Yeah. So we added the Y because it sounds cool.
Yeah.
I just want to ask you a question before we start. What is your favorite feature with Ivy?
The fact that we can make ng modules optional. That's it.
Yeah.
Because since it is slightly more dynamic and slightly less restrictive, and because of some architectural changes, we can finally make them optional. And ng module has been a useful concept, but at the same time a little bit confusing, especially if you're getting started with the framework. So having the opportunity to make them optional.
Yeah.
I think also the developer experience will be enhanced with the static template, static typing. Yeah.
Yeah. Sorry, guys. Yeah, the winner is DBLS VS. Thank you guys for participating. And thank you, Minko, for joining us today. We really appreciate that.
Sure, yeah, thank you for having me. And great job with the quiz. That was a great idea.
Thank you, all of you guys, for watching us as well. And see you next time.
Bye-bye.
Bye.
Bye-bye. See you.